This is Justin Jeans with ECE 495, group number 14, and this is video update number 2. Last week Jesse told you a little bit about the design that we decided to go with, and that is using two motors spinning side by side to create a force on a ping pong ball. This week we've taken that a step further. We've done a lot of research on some similar systems such as football throwing machines and baseball pitchers. We looked at how those machines use the wheel system to inflict force on a ball, and we've also done some heavy research on how putting spin on a ball can actually affect the trajectory of the ball to curve to the left or to the right. And that's really where we've spent most of our attention this week. We went down to the lab, created a very simple prototype using two fan motors from an old PC, and we set up a system in which we varied the speed of those two motors and saw just how effective that difference in the speed was on affecting the curve of the ping pong ball. It turns out that it works pretty well. At first we were a little disappointed because it took several feet for us to see the curvature in the ping pong ball that we were looking for. So we then went back and discovered that if you change the direction of one of the motors so that it's actually pushing the ball back inward towards the feeding mechanism, you can put a more drastic spin on the ball, which causes it to curve in much less distance. Unfortunately, it still was not quite the effect that we need for the final game. So, through some further experimentation, we found out that we can control the curvature of the ball also by affecting the angle of one of the motors. If these are your two motors and you turn one of them up, it's going to put a spin on the ball which causes it to curve to the right. If you point the left motor down, it causes the ball to curve to the left. And this is a much more drastic curve than what we were seeing just by varying the speed of the motors. We saw that we could curve the ball within just a foot or so. And that's just the kind of response that we're going to need for our final design. So our prototyping and experimentation are going really well. During this prototype, we used voltage sources in the lab as our power source to our motors. Of course, we're not going to be able to use that for the final design, so this week we're going to focus some of our attention on our control systems, creating a pulse width modulated signal coming out of the Quasar Q4 board and using a AC to DC power converter, such as the power supply out of an old computer, to amplify that signal to a point we could use it to power our motors. Jesse has been working heavily on the image processing part of our project this week. We've taken a similar approach, but different to that offered in lecture a couple of weeks ago. Instead of looking at threshold voltages, we're actually taking a picture, looking at the picture taken directly before it, and telling what's changed in that time span. If we keep track of that as the game develops, we think that we have a much less error-prone way of telling what the game state is. So this coming week we're going to be working on that even more. We've also done a little bit of research this week on our tic-tac-toe algorithm. We know that's going to be a very important part of winning the competition. In the coming weeks, we're going to spend even more time sitting down, taking a look at the game rules that we have and figuring out exactly how a computer could break it down into a game-winning algorithm. As far as our schedule, everything's moving along wonderfully. We're going to be working on a more stable prototype this coming week so that we can get some more constant data, some more reproducible results in the lab to try to figure out just how much changing the angle of one of the motors and the speed of the two motors together can affect the trajectory of the ball. So in this next week we're going to do some more development with that, as well as putting together the entire system, the controls, the image processing, the algorithm, and the hardware implementation. We're moving along quite well on our schedule though. Everyone on the team is doing a great job. Everyone works together well. We've each got our strengths that we bring to the table, and I think whenever we combine them all together, we have a truly unstoppable team. and I think we're going to have a great update to give to you for video update number 3. Thank you.